Welcome, everyone. We're going to get started in just a couple minutes. Want to give another minute or two for folks to join us. All right, let's kick things off. I'm Ryan Goins. I'm the head of product here at ObserveIQ, and this is our Mastering OpenTelemetry series. So for today, we're going to be starting with OpenTelemetry 101, but we'll have future sessions diving deep into the OTel collector, how to build your own collector, building pipelines, managing high volumes of data, and doing instrumentation with OpenTelemetry. So lots of stuff coming. Today, we're going to start with the basics. And to do that, I'm going to hand things over to Mike Kelly. He is the CEO of ObserveIQ.
Thanks, Ryan. And thanks, everyone, for joining. Really looking forward to digging into this with everyone. I'll just mention, if you have any questions along the way, feel free to just ask them in the chat. We'll try and answer those either as we go through or happy to answer them after, assuming we have some time. But just a little bit about ObserveIQ to kick things off. We've been major contributors to the OpenTelemetry project for a few years now. The log engine within OpenTelemetry is something that we developed and then merged with OpenTelemetry a couple of years ago. And we've developed BindPlane, which is a unified telemetry platform designed specifically to manage OpenTelemetry at scale, to make it easy to manage, and ultimately to allow you to reduce your costs, your security, and observability spending. So we've been focused on OpenTelemetry for a long time, and so we love to talk about it. I love to get into some of the details. Today, the focus is really just a quick overview of OpenTelemetry. I'm sure a lot of folks on the webinar already know about OpenTelemetry, so we won't spend too much time on that. But then a little bit about what we recommend for getting started, deployment options, particularly for enterprise companies and deploying at scale, how you handle migration if you're a large company that already has a observability infrastructure built out, and a few other considerations that we think are important as you're thinking about switching to OpenTelemetry. So I'll start with what is OpenTelemetry. And, OpenTelemetry is a lot. It's a very large project, but I usually break it down to three components. One is the protocols that it defines. So these are very well-defined protocols, include specifications and other standards for collecting, processing, and transmitting all of your telemetry data. So it's very well defined. The most commonly mentioned protocol is OTLP, the way the data in telemetry is structured as it's sent through a pipeline or sent to a destination. It also includes instrumentation, and this is really where OpenTelemetry started out. Started as a set of libraries for collecting traces. And this is a whole SDK ecosystem, lets you instrument your custom applications, supports the majority of the programming languages we see in use today, and also includes auto instrumentation as a piece of that for some of those languages. Then the last and another major component is the OpenTelemetry collector. And this is really designed to be vendor agnostic, as all of this is vendor agnostic. This is a vendor agnostic agent designed to support traces, metrics, and logs, and then also builds in a lot of additional functionality for processing that telemetry, routing that telemetry, and acting on it in a number of different ways. So if you think of those as the three big components to OpenTelemetry, the next question is, why would you adopt it? And there are a number of reasons, but we think the biggest reasons are, if you adopt OpenTelemetry, you're really learning one set of APIs, one set of conventions. You are breaking away from proprietary formats and agents. You really own the data that you generate. And we break that down into a few things. One, you standardize and simplify. So rather than having a half dozen or a dozen different agent types or different frameworks that you're using, you have one, and it's well supported across the industry. The next is that's vendor neutral. So this has been a stated goal of OpenTelemetry from the start, and you'll still see it on the website as a key goal, was to provide a vendor neutral solution. And that's great in theory, but in practice, that's really what we're seeing. And it's nearly the entire industry is backing OpenTelemetry, supporting OpenTelemetry, and even contributing to the OpenTelemetry project because it's really seen as good for the entire space. And so the last piece, really, without that industry backing, industry adoption, it would be really difficult to recommend adopting OpenTelemetry. But we have seen that. We've seen adoption across the industry. It's a Cloud Native Computing Foundation project, one of the largest. It's the second largest, only next to Kubernetes in terms of the number of commits, the number of people involved in that. And like I said, really supported by the vast majority of observability vendors today, including native support. So most vendors have either an exporter that supports their destination, or they just support OpenTelemetry protocol natively. I add this because it tends to be a question that comes up a lot, because for quite a while in the early days of OpenTelemetry, there was a real focus on making sure that this was a rock solid solution. And so the community and the project were hesitant to ever call something stable until it really had been proven out in the field. And that was even with things that were in production, and lots of large customers. So when we look at it now, we see that the stability of logs, the API, the SDK, the protocol, those are all stable. It's been added to the collector. And that was part of the donation of our log agent to OpenTelemetry. On the metrics side, the API is stable. SDK is mixed, and that's primarily because there's so many different metric solutions that are available within the project, but you can easily go in and see what the status of each of those is. And then the protocol tends to be the most important. This is stable as well. And traces, which was really the first major effort by OpenTelemetry, it's not surprising that all of those components are stable. So just calling that out because it tends to be something that in the past might have been a concern, right? And what we've seen is a lot of growth and development in the OpenTelemetry community and the project itself. So this is really what I think of as the ideal state for OpenTelemetry in production. And as we're talking through the steps to get started, and also the pieces to consider, a lot of it is with this in mind. And this is what I think of as creating a data plane, a telemetry plane. And this is building out your telemetry infrastructure so you have a single system to learn, single system to deploy and maintain, dramatically reducing the complexity, especially in very large environments. You control your data, you're not locked in, and you can easily reroute data and add or remove solutions whenever you want to. And this is what that looks like. And each of these boxes will use similar diagrams. This would be an OpenTelemetry collector, and another collector building a pipeline, streaming the telemetry data, deployed as an agent, deployed within an application. And we'll talk through the considerations to get you to this state, and also talk a little bit more about why this is an important state to get to. So we'll start off with getting started. And the first step here is also sometimes the most tedious, right? But it is understanding the environment that you have, uh, doing a quick inventory on what you have, and making sure that everything is covered and having a plan for how you're going to roll this out. So when you standardize on collection for metrics, logs, and traces, you need to ask a few questions. You need to understand the environment. So just some quick questions to get you thinking about this. But what languages are you using in your applications? So if you have custom applications that you intend to instrument, make sure that those languages are supported today. They probably are, but it's good to validate that. And you can also understand whether they have features like auto instrumentation available. Will it need to be will code need to be modified? Are you able to support all of those with it today? And if not, are there options to move in that direction in the future? Similarly, with what type of metric sources you intend to ingest. So it's usually the easiest way to do this is to look at your existing systems and understand what you're doing currently, and then map those to OpenTelemetry. Same thing with the types of logs, and then where you intend to send the telemetry data. And so these are just the core components. Instrumenting applications, metrics and logs you're trying to collect. What do you need to do to process those? Where are you sending the data? And the last one that I'm not asking here, but it is something to consider, is how do you need to process and route that data? And that is something that OpenTelemetry does very well, and that's likely to be supported, but it's really understanding all of those pieces so you can plan what the rollout looks like. And one thing I'll call out, I have some resources here, but one that can be really useful in this, and we'll send out an email with links to these after the webinar, but an OpenTelemetry registry that lets you know everything that's available within the project. So I can look for something. If I'm looking for Postgres, for example, I can do a quick search and I'll see that there is a receiver available. There is instrumentation that's available for that as well. I can do some, we're looking for applications, looking for Aerospike. And there's a long list of pre-built receivers for applications. Also, the ability to support custom implementations if you want to pull data from common sources, say like syslog, or shift to a different format, raw files. You can do all of that with OpenTelemetry as well. And that's a great spot to start and to understand as you're going through an inventory. The other, I think, great resource here, obviously documentation. This is comprehensive. It's a really good place to go. But another that I'd recommend is the OpenTelemetry demo. This is a easily deployed OpenTelemetry environment using all open source components, but it really touches on a lot of the different things that you can do with OpenTelemetry and helps you understand what's possible and ways that you might want to use OpenTelemetry in your environments. Once you have a good sense of that, the next step is understanding the collector distribution. And this is an area where there can be some confusion at first because there are so many different distributions. You can think of this like Linux, right? With Linux, you can choose from 100 different distributions. It can be difficult to understand what makes the most sense for your environment. And so I break it down into 3 different types. There are the official distributions, of which there are only 2. There's the OpenTelemetry Collector Contrib, and then the OpenTelemetry Collector Core. There are vendor distributions, and you can build your own distribution. So when we're talking about official distributions, the 2 distributions, and it's key to understanding the difference here. The Collector Contrib is the most commonly used collector that's out there right now. It includes the majority of the receivers, the exporters, and processors. So the metric receivers, the exporters for different destinations, and the processing is all built into the contrib collector. This we think is a great place to start. It can be overkill for some deployments if it's a really critical that it's slimmed down in just the minimal collector, but we find in almost all cases that this can be used out of the box. When it comes to the OpenTelemetry Collector Core, this can be confusing because this is really designed as just the bare minimum that's required to run a collector, minimal set of components. it's unlikely to support all of your use cases. And so typically not recommended for deployments, and very unlikely to work as you scale and as you are looking for additional functionality. When it comes to vendor distributions, these are typically, when we talk about pros, these are typically supported by the vendor. I'd say the one thing that you really want to be careful of when you're selecting a vendor distribution, or if you're considering a vendor distribution, is that they can easily include or exclude components, and they may only be the components necessary for that platform. And if that's the case and you deploy this widely, you can end up in the same place that you were before, where you tend to be locked into that specific vendor. So if they have a distribution that only allows you to send to their platform, it can be challenging. If you decide to send that data anywhere else, you're going to be required to go through and update collectors throughout your environment. So if you do see a vendor distribution that you're considering, I would just recommend that you review the components that are included in that. We'll talk in a second about how you can do that, and make sure that it covers all your core use cases. I'll mention now that ObserveIQ does provide a open source distro, and this the BindPlane agent, and this does include a wide range of components, including some additional functionality that isn't in Collector Contrib. So if you're looking for one that you don't want to build your own, Collector Contrib, or you can choose a vendor distribution that has, ideally, a wide range of support for different solutions. And the last piece here is to build your own. And this, in the past and still sometimes today, can be recommended as a route to using OpenTelemetry. It does allow you to just choose the components that you need. You can build your own custom components. So if you need to build a receiver or an exporter for something that you have within your environment, you can do that. You can develop it and package it in with the collector. I think the downside of this is that you end up managing all of your own maintenance, updates, support. That's all handled internally. And it can be, a bit more of a lift to get started with this. If you do pursue this, and we'll do a webinar specifically on building your own collector, so I won't get into this too much, but I did want to point this out. The key place, and probably the first place to start, is this manifest. And there's a lot here, but it's easy to understand as you go through it. This is just a list of all of the components that are packaged into this collector release. So if you scroll through these, we could see the extensions, the exporters, the processors, and the receivers that are included and built with this collector. And so if you are doing this, I'd say one tip I always give to anyone building their own collector is to use the OpenTelemetry Collector Builder utility and start with the OpenTelemetry Collector Contrib manifest. So take this, it may have more than what you need, and remove the items that you don't need in your distribution. And that's going to be the most stable distribution. I think the most stable place to start from until you have a really, really strong understanding of OpenTelemetry. And the last tip on this, when you're looking at replaces, if you are considering this, we recommend leaving these in place. So these are specific replacements that tie back to one of the receivers or one of the connectors. It's not always documented really well which applies to which, but by removing those, you could introduce some unexpected issues within the collector. So those are the considerations: the official distro, vendor distros, or building your own. And particularly because I think there is so much to OpenTelemetry, and so frequently people say, well, these are your dozen options. We do like to try and give recommendations. So if we look at collector distributions, for most people, we think a great place to start is with the OpenTelemetry Collector Contrib, or with a vendor distribution that has a wide range of support for your infrastructure. I say the BindPlane agent matches that case as well. But using a collector like that has a wide range, has good options for deployment, is a great place to start. You start there, you can test it against all of your core use cases, deploy it in POC environments or early environments, see if there are, if there is anything that you really truly need to develop on your own, or if you need to maybe reduce the size of it. And if any additional functionality is needed, or you think there's some additional optimizations you want to add, then I would say you consider building your own. So that's, a key step in this. The next is, how do we deploy it? And there are a lot of different ways that you can deploy OpenTelemetry in an environment. The answer you sometimes get is it depends. I'll give an opinionated take on this, but I want to talk about the different models that are common. So first I'll start, I'll explain a bit about this diagram. If we look at this, this is a host, single application running on it. That application is instrumented with OpenTelemetry through the SDK for traces. The host has an OpenTelemetry collector installed that is receiving that trace data and then is sending via OTLP to a destination. And in this case, it's a APM platform. So this model, very common. It's a way that is really easy to get started. It's really clear, the mapping between the application, the collector, and the destination, but it isn't very flexible. And as you scale out, you run into challenges with this, and you run into limitations. Now, there is one before this that I don't typically recommend, but you can send data directly from the instrumentation right in your application to a destination. That is a great place to test, but it's rarely good for a production environment, which is why we exclude it from the deployment patterns we mentioned here. But with the agent deployment model, you still can send data to multiple destinations, and that is, a significant benefit. You can use this collector to gather metrics and logs from the host, as well as the traces, and then you can route it to multiple destinations. So again, really easy to get started and not a bad place to start if you're testing things out and validating. Not usually the best for production environment. And the gateway model, which would be the next step up in deployment patterns, is one that we can say we can recommend this for production, or at least this is the first of the models I'm going to show that we would recommend for a production environment. And similar to what you saw, there is OTel instrumentation within an application, but now you can imagine you have a dozen or 1,000 or 10,000 of these hosts. Maybe they're in a Kubernetes environment, will look very similar to what you're seeing here. And you have the agent deployed just like you did before. I have in parentheses here terminology differences. These are both OpenTelemetry collectors. They are the same binary, can be the same binary, but they're used in different ways. And sometimes you'll hear them referred to as an agent. It's deployed on the host that has the application, and a gateway if it's deployed outside of that host and is operating as really a gateway for all of your telemetry data. And the great thing about this model is you have a local agent, allows you to collect log metric data from that node. You are offloading the data from the SDK, and then you have a gateway that's able to do additional processing. We'll talk a bit more about that in this slide. So the agent offloads trace. It allows you to collect metrics and logs. It does any pre-processing that you need on that data, and can also implement some caching. So if it's critical that you don't lose any data, you can have a small cache at the host itself. Then at the gateway, it allows for heavy processing. So if you want to delete information out of the telemetry, or let's say you want to standardize or add additional metadata, that can all happen at a gateway. It also lets you route easily. And when we talk about compliance here, it may not be what you're the way you're used to hearing it, but more and more folks that manage large observability infrastructure are look to the gateway to ensure compliance across application teams. So making sure that the data that is coming in matches certain standards that you've set in your organization before it's passed along to a destination. So those are all some of the benefits that you get out of this gateway model. And the gateway model scales really well. So you can go to a high availability mode, scale out those collectors or those gateways with a load balancer in front of it. Now, really depends on your use case, whether this makes sense. It does add some complexity. If your data volume is very low, if high availability is not critical in this component, then you may not want to follow this model. But if you're dealing with very large amounts of data, or if you have high processing needs, have really strict high availability requirements, then this is a great model for your deployments. And ultimately, it gets you to what we talked about toward the beginning. It's really creating this telemetry plane, lets you scale, very highly scalable data plane. It's all using OpenTelemetry. It's easy to switch and route telemetry. You don't need to re-instrument every time you want to try a new platform with a vendor's SDKs or a vendor's agents. This is an incredibly flexible pipeline, and it allows you to do some pretty advanced things once it's all in place. So the next, I think, probably biggest challenge when you're moving to OpenTelemetry, if you know the deployment model you want to follow, you have your distribution selected, you really understand OpenTelemetry, then the biggest challenge, especially in a large company, is how do I migrate to OpenTelemetry, right? This can be one of the places that stops a lot of folks from going forward, is they just don't know where to go first. And so we recommend a staged approach. If you have a large observability infrastructure, you have instrumentation in place, you have agents deployed, we recommend that you go step by step in migrating to OpenTelemetry. And if in this diagram, the red would indicate either proprietary or other open source instrumentation or agents deployed within your environment. So whenever possible, I always recommend that the first phase, if you have any greenfield deployment, so if you have new applications being developed, and if you don't have that, I would say a team that is interested in migrating to OpenTelemetry, starting with one of those and putting in that initial deployment model. And what this does is it lets you validate that this is going to work within your environment, that you're not going to run into any challenges, or that there aren't any data formatting issues that you may need to resolve before migrating it more broadly. And you'll also the team gets familiar with OpenTelemetry. You'll understand what, if any, differences there are within the other platforms. And then once that is really well understood, it can be much easier to roll it out to other teams and convince other teams that it makes sense to switch over to OpenTelemetry for the benefits you can show in your phase 1 deployment. Phase 2 is one that not everyone realizes you can do with OpenTelemetry. With almost all instrumentation or agents, the vast majority of these, whether they are proprietary or open source, you can redirect that telemetry data to OpenTelemetry. And you can almost find a format that OpenTelemetry supports, or a generic format that the agents or SDKs that are already in place can generate. And when you can do that, then just by redirecting that data before you re-instrument, and sometimes the re-instrumentation can be the biggest challenge. If you redirect to a gateway collector or a fleet of gateway collectors, then you're pulling all that data into the same pipeline. You can do it application by application or team by team, but you're pulling it all into the pipeline, and then you get all the benefits of the processing that can happen at this stage before it moves forward. So that gives you the processing, the routing, and the standardization on OpenTelemetry without re-instrumenting things throughout your environment. And then the last phase is to really replace what you have in your environments with OpenTelemetry instrumentation. And in most cases, you can do that throughout the company, throughout the infrastructure. We also realize that in some cases, it may not be worth it. You may have legacy applications and no one wants to open up that code base. There may be places where you don't want to touch an agent that's in place and working. And so you can just leave that alone, right? But the majority of these can be migrated over to OpenTelemetry. And then you've really achieved that unified pipeline that you're looking to achieve. And you have all the capabilities we talked about, the processing in place, and the flexibility going forward. A couple of other items that we wanted to dig into within OpenTelemetry, things to consider as you're considering adopting OpenTelemetry or moving into the OpenTelemetry environment. And this really comes back to the benefits of building that pipeline. Once you have that infrastructure in place, within the OpenTelemetry collector, it's very easy to take the data. So we describe this OpenTelemetry architecture diagram first. We have, in this case, we're receiving data. These are standard OpenTelemetry receivers, very basic receivers, can receive OTLP, can receive host metrics, and can receive a raw file. We can apply within that pipeline processors as it's moving through. So each OpenTelemetry collector will allow you to do this. We can implement things like batching or adding attributes or sampling or filtering. Also deduplicating and redacting or masking out data, and then routing it to the correct exporter. And all of this can be done within a single OpenTelemetry collector. And that's something, we have a full webinar dedicated to this topic specifically, how to build out a pipeline and how to use OpenTelemetry to do that. But once you have this in place, this is probably one of the most powerful things about having OpenTelemetry in your environment is all the abilities you now have to process data and then manage, export data to different destinations, receive data from different infrastructure software. Another, and this is a newer feature of OpenTelemetry. This is called the Open Agent Management Protocol. And the OpAmp, you'll hear people abbreviate it as OpAmp frequently. This was designed because of a need from a range of vendors. So like I mentioned before, the OpenTelemetry project has dozens of folks from major observability and cloud providers all contributing to this. And what we found is that many of us had developed this agent management protocol on our own. It was proprietary. And in the spirit of OpenTelemetry, wanted to standardize what that looked like. So when we talk about OpAmp, this is a network protocol specifically made for managing collectors and doing that at scale. So when we designed this, it was designed to manage very large fleets. We're talking about hundreds of thousands or millions of collectors. And not just collectors, although that's been the focus so far. This is a generic protocol that can be used for really any type of observability agent. But starting with OpenTelemetry, if we look at this, it's a lightweight protocol that requires an OpAmp server, an OpAmp implementation, and then the correct component available within the collector. So when you think about building your collector, your OpenTelemetry collector, that would be something you'd want to consider including or not including, depending on how you're going to use it. But because this is a lightweight communication protocol, it's designed to scale. It allows you to control fleets of, like I mentioned, hundreds of thousands of agents or collectors all at once. And this is something that is fairly new. Some folks would argue that you can deploy this with Terraform or Ansible or some other DevOps automation solution, and that is enough to manage these. What we found is that frequently, in many cases, having dedicated capabilities to manage these and also having visibility into the data flowing through collectors, having real-time, the ability to change things in real time and deploy new updates is really powerful, especially if you're dealing with things like a growing, rapidly expanding telemetry or rising costs. Having this type of visibility is key. So a few things about OpAmp and things that it includes. Um, First of all, and probably the most critical, is it allows you to configure a collector remotely. So you can push down updated configuration. You can also look at the agent's own telemetry, so see how an agent is performing. You can manage connection credentials, also report the status. You can upgrade an agent. So this is a project that's developing quickly. There are often new receivers or processors that you may want to include uh, throughout your infrastructure. You can use this to push agent upgrades as well. And that also includes secure auto update capabilities. So auto updating those agents and doing that in a secure, validated way. And there are a number of resources here. This is, while everything else that we've talked about has been, in OpenTelemetry for quite some time now, OpAmp is a bit newer. And so there are a couple of links that we'll share going forward to give you an introduction on OpAmp, the spec, and so you can understand whether this is suitable for your environment. So we're going to have some time for questions in a second, but before we jump into those, I want to talk a little bit about BindPlane as a add-on to that OpAmp discussion. As BindPlane is our platform designed specifically to manage OpenTelemetry collectors at scale, and give you the visibility into your full telemetry pipeline. What that lets you do is you can quickly reduce costs through smart data reduction. You're simplifying the management and reducing the complexity of managing OpenTelemetry at scale. And everything that you saw us talk about that you can do manually with OpenTelemetry, you can do with BindPlane, do it faster and easier. And then it gives you the added on visibility through OpAmp to really understand what's happening within your environments. So I'm going to pause, and we've got a little bit of time here for questions before we wrap up. As Ryan mentioned, we have a full Mastering OpenTelemetry series that is kicking off with this OpenTelemetry 101. Next, the OpenTelemetry Collector, a deep dive, is going to get into the details of how you configure a collector, the components that you can use. Building a custom OpenTelemetry collector gets into how to use the OpenTelemetry Collector Builder, things to consider as you're building that out, what you need in a manifest. Next, constructing an observability pipeline, the pieces that we talked about here, how to pull together OpenTelemetry collectors, manage that pipeline inside of individual collectors, but also combine them together throughout your infrastructure, and more as we go forward. And of course, always open to hear if there are things that you're looking for that you're really interested in hearing more about. But I will pause there, and Ryan, see if you have any questions I can answer.
Yeah, it looks like we've got one question, Mike. How does the collector scale? What throughput can it handle?
Great question, and probably the best way to answer that is with some benchmarks. So because it is very different depending on the processing that you're doing inside of the collector, the best way to look at this is what is it doing at if you're just ingesting data. So in the model that we showed, we have an OpenTelemetry agent. That's going to be the highest performance. You can look at benchmarks to see the full throughput of an individual agent deployed in that mode. A gateway by itself may allow for less throughput, but then it would be designed to scale out the mode that I showed before in an auto scaling type of environment. What I can do is share some of the benchmark details that are run and managed as part of the OpenTelemetry project. And just say that when we compare OpenTelemetry to other collectors and agents that are on the market today, it tends to be very well optimized agent. It's written in Go. There's been a big focus on performance for this. And like I said, really has the entire industry looking at how to make this a performant collector that can really manage just about any type of telemetry data.
Great. We've got a couple more questions that have come in. How would you think about OTel agent for Internet of Things with, say, manufacturing or oil and gas business processes and underlying infrastructure use cases?
Yeah, it's a good question. So we've seen a decent amount of customers starting to use this for Internet of Things, and there are really two approaches that you can take. It depends a lot on the um, what you have at the edge. So in many cases, what we would consider is a modified gateway architecture. It's what we see some customers doing, where they have a gateway that maybe has 1,000 IoT devices that are sending data to that gateway. And then it fits right into the same model where you can manage all that data, you can filter it at the gateway level. But we've also seen end users that want to deploy and will deploy OpenTelemetry directly on those IoT devices. And that's a common scenario as well. And that's one where, depending on the size and resources of that device, you may want a slimmed down collector with just what you need. And in those cases, it can be extremely performant. It can do, and you can tailor it to the specific needs of your specific IoT devices. So in that model, you would have a custom OpenTelemetry collector or a slimmed down OpenTelemetry collector that only has the components that you need, that isn't doing any additional processing. So you wouldn't implement a pipeline in that collector, and you would forward it to a gateway. But this is something that we see more and more interest in. Those tend to be very, very high scale in terms of devices, environments, because it's just a great fit for environments of that type of scale in terms of agents for sure, different types of telemetry.
All right, a couple more. Can you comment on OTel security and design considerations?
Yeah, so it's kind of a broad topic, but I can talk about a few pieces of this. So if we want security design considerations, the specific project has had a major focus on security from the beginning. And in fact, that was one of the, when I said the project was a bit conservative to saying something was stable, for example. There was just about every decision in the specifications and then carrying through to the implementation went through round after round of debate about whether this made sense for the project itself, but also was this a secure component that would meet the requirements of nearly every vendor in the industry. And there were some things that were pulled out of the collector and the protocols for those reasons. I can think of some receivers that that there was nothing particularly insecure about them, but they had maybe a broader there was more opportunity for those to be misused. So there is a big focus. There are a lot of eyes in the project. As I mentioned, it's second to Kubernetes, and the typical security scans that you'd expect, and the processes and the review processes that you'd expect as something is developed. They're all happening within OpenTelemetry as well. So hopefully that answers the question. Happy to answer any of those after as well.
Great. Looks like we've got two more. I love this one. In the future, would BindPlane OP be able to manage OpenTelemetry collectors, contrib or core, and/or configs?
Yeah, it's a great question, and it's something that we are actively moving toward right now. So with the latest release of BindPlane, it does support connecting to OpenTelemetry contrib collector. So that's a feature that was fairly recently added to the collector, and we're adding more of the functionality to get it to full management, so that this will be a fully native experience. You can use an OpenTelemetry collector directly from contrib, or you can build your own with your own components that define specifically what you need, and we give you a set of components that are needed to enable op-amp as part of that. So yeah, something that we're very excited about and are moving toward very quickly.
All right, last one. Does the collector run on Windows?
It does, and that's a great item to point out. I think one of the things we focused on with BindPlane and the BindPlane agent was making it easier to get started with Windows. So uh, Collector Contrib does support Windows, but it doesn't have all the maybe niceties of what you would see in Linux. So Linux distro has good support for different packages and package managers. Um, Windows was required a couple manual steps as part of the deployment. So if you're looking for something that out of the box supports Windows, has all the installers that you would typically expect, I'd say give the BindPlane agent a look. That particular distro, our distro, has I think some slightly better experience for Windows users. But not to say that plenty of folks are using OpenTelemetry on Windows in production directly from Contrib. So fully supports Windows.
All right, we got one more. And we still have, oh, actually two more. We've got about 10 minutes here, so keep the questions coming if you got them. Will you be sending the URL shared earlier in the slides regarding hotel resources? We definitely will be doing that. Also, we are currently exploring BindPlane to bring our logs from existing log aggregators to GCP. Can we use BindPlane to also fetch metrics and traces?
Yes, you can. So BindPlane was designed really to handle all three traces and beyond. So if you have this installed, there's really nothing additional that you need to do other than for traces, you can instrument your code, and then you will have, or if it's already instrumented, just send it to a BindPlane agent, and then it will automatically be a part of that pipeline that you're building. So there's nothing additional that you need to do. Logs, they're supported out of the box, or if you're building it, logs are supported out of the box. You'll get metrics and traces as well without upgrading, without turning any features on. It's just there.
All right. Is the BindPlane OP server available on Mac for testing?
So we don't officially support Mac. It's a good question. So I'm supposed to answer no to that. No, it's not. There's a good chance it will work because we do use it on Mac, but it's not a supported path. So it's not something that we recommend. You're likely able to run it on Mac though.
Currently, we are using New Relic for our APM metrics. Do you believe OTel can fetch the same amount of metrics as New Relic or any other vendor tool?
Yeah, that's a good question, and I would say in most cases, absolutely yes. It's one of the reasons why it's important to take a look at what you have in your environment, what's there within OpenTelemetry. But if you're looking for, APM metrics, certainly traces, I think anything that you can instrument and collect with New Relic, and in fact, New Relic it supports OpenTelemetry natively now as well. So you're very likely to find parity or more with OpenTelemetry, but it can be case by case. So I'd say part of our contributions to OpenTelemetry have been to develop over 30 of the metric receivers and then an additional 50 or so log parsers. And so that was expanding what was already there. I think in total there's like 80 receivers, 80 or 90 receivers that are available, and really wide support for generic formats as well. So if there's something that it's in a standard format, but it's maybe not named as that product that you're intending to support, that may be available for you as well. So to summarize, the answer is probably can do everything that you need to and everything that is available there, and then some. And either way, it's probably worth shifting, but you'd want to take a look, just dig in a little bit, especially if there's anything that's absolutely critical to observability for you.
All right. Any last questions? I'm not seeing any. Cool. It looks like that's it.
Great. Well, I appreciate everyone joining, and hope you can join for some of the upcoming webinars. And have a great day. Talk to you
Thank
soon.
you all.
Thanks.